Okay, so welcome to our CCNA Security Instructor Training class meeting for March 1st. We're going to finish up Chapter 2, and we'll pick back up first off with the SNMP section, but we want to review just a second about how we are looking at ways to secure the management plane of a router or device, the data plane, and then the control plane, because those are all items that we're looking at here. And this would be, when you're looking at SNMP, part of the control plane, where we're looking at SNMP as a protocol has been a security issue for a while, simply because the first two versions of it, SNMP v1 and 2, had no ability to do authentication or any type of control between your managers and your nodes. In fact, there were well-known tools out there where for SNMP, the read-only password was public, and the read-write password was private. And so you could actually drop a tool onto a network and get access to devices using SNMP with an SNMP walker. I know people have done that and ended up inside of Cisco routers and switches that had not been correctly configured. And part of what we look at when we look at traps, SNMP traps can pull information from a device, and the information it can get and also set. So it's not just getting information with a trap message, but you can also set items on a particular device, are based upon the MIB, or the management information base. And all of the different things that you can do on a Cisco device or router has a MIB as part of it. So you can actually go in and see what you can do on a device. It's starting to really rain hard here, so I hope the power doesn't go out. If it does and I drop offline, then you know what's going on. I do have a backup, but it won't stay up for long if it's a long outage. But here's our different versions, and you'll notice that up until we really got in SNMP v3, there was no authentication or encryption available. But now with SNMP v3, which should be the only one that you use in the modern world, you can use MD5 or SHA, SHA being a more secure form of authentication, and you can encrypt the traffic using AES. And that makes it a much safer system to use. How familiar are you with SNMP as far as overall? Okay, having the same problem there. Well, if you not get knocked off, I know exactly what happened to Scott. So I believe this entire storm is moving through up the East Coast and turning into that bomb cyclone. But what we have here is some management console. Okay, so basically you can set up an SNMP management node, and that sends out information and request. You can set up traps, and you can actually go out and ask for the management node to request information from an SNMP device, or you can set items. So a trap can be set up to when a certain threshold, let's say for instance, a good example would be the processor on a Cisco router goes higher than 80%. You can have it set to where a trap will immediately be sent to the SNMP manager and say, you've got a CPU on this router or firewall that's at 80% or higher. You also can use GET messages, and those messages will just simply go and say, hey, tell me your IP addresses, tell me your iOS version, tell me whatever's in the MIB is what you can pull from that device. Likewise, you can even do set, so you can set some items. So if you want to set the status of an interface to up or down, or set other common items that are in the MIB, those are items you can do. Well, again, if you used an older version that did not have encryption and authentication, many people use just a plain text. The easiest way to think about it was like a work group name in Windows, and the defaults were private and public, and many people left them that or made them something that was very easy to see, because these things went across the network and could be sniffed, and then you could use your SNMP manager running on your hacking box to make changes or to at least pull information and use it to grab information on the network. With V3, this is what we've got now. You've got an encrypted tunnel between the network management station and the managed nodes. And so you also have the ability to do access control, to do specific portions of data. So you can go in here and you can say, use encryption, and then also set up where it has access control using access control list, and we'll show you that in a moment. So definitely, if you're using SNMP3, SNMP, use version 3. Do not use any other version on your network. So here's actually configuring some security, and you can see here you do an access list named ACL, and you did permit source net, and this will be your management network. Okay. Then you do SNMP server view name and the OEID tree, which is part of the MIB. Give it a group name, tell it to be version 3. And you're going to say priv view name, that'd be this view name from up here, access the ACL name. So it's going to say only these have access to these items, and then you can set up a user to configure as part of the group. Now, this is just a base configuration they're showing to you. We're not really doing a great deal with it because we're not going to do a full discussion on SNMP. This just shows you a simple way to secure basically SNMP3. So here's our configuration example in a little more detail. So we create an access list that says permit this management network. We're going to say server view SNMP read only, ISO included. All right, so it's going to be your included MIBs. Okay. And it's SNMP server group admin v3 priv read SNMP access, and basically saying this group of users named admin are going to have the ability to have read-write access. And then you put a user Bob in that group and do SHA and authentication, and then you're able to actually use that to authenticate, set up SHA, and have encryption across the link. It is, again, the only way that you should be using SNMP, and that ensures that you've got encryption and that encrypted tunnel. You also restrict who can get onto that particular management network. Show run include SNMP will show you your group names, or show you your access permit admin, which actually goes down to the access control list. It will tell you what the view is, read write or read only. And then you need to do show SNMP user, will show the user. This is then set up inside of the SNMP Manager. So you've got Bob, authentication protocol SHA, private protocol, or encryption protocol, and then the password. And that would be, this would be set up depending on what tool you're using. This happens to be MIB browser. And then you can set up the GET request and do that because you are now able to log in, or you're able to have secure access. And when you try to encrypt, or you try to look at those SNMP packets now, they're encrypted and you cannot get access to them. And that's that SNMP MIB browser, which is the free one that we use. And there is a video on YouTube.
SNMP version 3. In this short video, we'll take a look at how to configure.
So don't be afraid to jump out and use those videos. Students obviously love them, and it's something that we try to use as much as possible. Now this one is one that's easy to forget. We do a little bit with it now, CCNA. In fact, I would tell you this, that the CCNA security is much easier now because of what we do in the CCNA. You know, network time protocol is covered in CCNA, but it's very important to stress it again in the security class, because if you're going to be using logs inside of a SIM system to try to verify when attacks took place or when events took place, then you need to have your time set correctly. Otherwise, you could very easily be in a situation where you catch someone hacking into your network and their lawyer says, well, Your Honor, that's at 3:30 in the morning, and I have absolute proof that my client was working third shift and was away from the computer during that time. And then suddenly you know, even if you can go back and say, well, our network time protocol wasn't set right. Well, then at that point, the entire integrity of your case could be compromised, because they could say, well, maybe your entire network is not configured correctly, and you can't really be trusted to say that this is the person who broke into your network. So normally we want to set up an NTP system, and that allows a master to go out to the master on the internet, and then that will be used to set the time for everyone on your particular network. So you're going to make the system an authoritative NTP server, NTP master stratum, give it a number. Its number of hops it is away from the authoritative source, such as the atomic clock. So you have to figure out how far the atomic clock is away from you. You then set up the software clock to be synchronized to an NTP server, so NTP server address, version, and then key and source IP. This will allow us to actually point the master NTP server using an IP address, so that we can then pull that from that master server, pull down its time. This will actually let you get NTP broadcast. It makes it simpler because you only get the information coming from an NTP source. It's a little less secure because it is a broadcast, and it's also a one-way flow. So it's not, the client doesn't request the time, it has to be broadcast. So there could be some discrepancy between the time on the server and the time that's there. So NTP, so you set up, I'm the master with this IP address. I'm going to provide all the devices with a synchronized time source. So R1 is that. And then so your NTP1 master, and however far away the atomic clock is, show the clock, and then it will be the clock, and this makes it the master. And then you go and say, okay, on R2, NTP server is 10.10.10.1, and it should synchronize its clock with R1. Now, that's all fine and dandy until someone hacks your network and makes their device the master and starts sending out incorrect time information. So to fix that, we do have NTP authentication. So version 3 of NTP allows you to authenticate. So you go in NTP authenticate, then you set your key, NTP authentication key, the number, MD5, key value, okay. Then you do trusted key, key number. This identifies the identity of the system which it's going to use. So it responds to the key, this key number responds to the key number here. And so when we go in here, we'll go NTP authenticate. So we're going to have authentication. NTP authentication key 1, MD5 is Cisco 123. By the way, never use that password, but this is what they're using here. And it says the trusted key is key 1. That's on R1. On R2, you would do the same. And then this would, once you've set up your other items, such as your NTP server, so this is above and beyond the server setup, you then have authentication between the two. So R2 is seeing R1 still as the master, but now we have authentication in addition to just the master being set. This will prevent someone from dropping a rogue NTP server on your network, doing their nefarious deeds, and then removing it, and then all of your logs have the wrong time on them. So very important that you use version 3, just like SNMP. Now this is, again, something they've actually put back in the CCNA, but CDP, Cisco Discovery Protocol, and LLDP, Link Layer Discovery Protocol. CDP is Cisco proprietary Layer 2 protocol. It is used at Layer 2 for 2 Cisco devices to form a neighbor relationship with one another. It has uses with Cisco's IP phones. There are some Cisco services that require it. It is proprietary, so there are some devices run LLDP, Link Layer Discovery Protocol, which is pretty much the same, it runs with the same features as CDP. It's just an open protocol. You can get a little less information, but it's still pretty much the same. The problem with either one of these is if you have hacking tools, and here's one obviously, Cisco CDP Manager, you can connect to a device and get all of this information. And you can see that, you know, I've now got the VTP management domain name, I've got the platform, I've got the iOS version, I've got IP addresses. So if you do not need CDP or LLDP, it is a good idea to just turn it off. However, when I say that, don't just go turning it off everywhere saying, well, my instructor said I don't need it, because you may very well have some Cisco phones or Cisco devices that need CDP to communicate. So be careful of that. Tell your students the same thing. You know, by default it is enabled, and you know, it's advised that you disable it on a per interface basis unless it's required. Same with LLDP. Configuration autoloading should remain disabled, not in use. FTP servers should be disabled. Same thing with TFTP, it should be disabled. All services that you are not currently using should be disabled. Some we don't think about are some of the minor services, TCP and UDP minor services, okay, like Finger and other old services that are out there. Finger service, which by default is enabled. You know, do we really need that? Gratuitous ARP, proxy ARP we do need 99% of the time. IP source routing, some of these things can be turned off, okay, depending on how your network is set up. How do you determine what you need and you don't? Well, you investigate these services and then see whether or not they are in use on your network. If they're not, disable them and then go from there. You also have the ability to use this little tool here, which is Cisco Auto Secure. Now, by default, Cisco Auto Secure runs in an interactive mode, which means as you go through, it will ask you to enter in the configuration information. You can run it in a no interact mode, which will then apply all of Cisco's recommended base security configuration on a router. You know, basically it will turn off most of these services here. So to turn off everything that would be considered non-essential. It does force you to put in a legal banner. It forces you to do your passwords on both console, V2I line, and the privileged password. It requires you to do NTP and secure it. It requires you to use SSH. And it will ask you to turn on TCP intercept services, which is a special denial of service attack service that can be turned on to help with SYN floods. It will actually start dropping SYNs if it sees the half open connection queue getting filled up. And then Cisco Express forwarding traffic filtered ACLs, and you're using the firewall as a CBAC or context-based application firewall. That is also something you can do with this Auto Secure. So let's take a peek here with the feature. So here's the command, Auto Secure no interact. We'll just let it run and put all that in. Auto Secure, just Auto Secure enter will force it to do request answers to every single item. To do Auto Secure Firewall, we'll set it up with only the firewall features. Do forwarding, only the forwarding features. Full is the interactive full. Login is only your login features, so setting up those passwords. Secure management, Auto Secure NTP, and then Auto Secure SSH and TCP. So you can actually run these as individual items and not do all of the changes that you would normally find in Auto Secure. But it's a good place to start. This kind of shows you what each one of those will do if you do happen to use that as the command parameter. Yeah, that's a good point, Scott, talking about not used it until now. Auto Secure is a really good place to start because you know, you may have to, for instance, it may turn off CDP and you may have to go back in and turn it back on, but it gives you that baseline. It's almost like, what is it, the Microsoft Baseline Security Analyzer, the MBSA, when they used to have it, and you could actually take from Microsoft and download a template that you could then apply to a base Windows system, and it would do all what they consider to be the important items that you have to set up. Yep, that's exactly right. MBSA, exactly what it reminded me of too. So if you do auto secure, it's going to ask you for first off information about is it connected to the router, how many of the interfaces are facing the internet, because it's going to wants to know which one of those are facing the internet. Then you have to tell it which one's facing the internet, because it's going to use that to configure the CBAC features. It's going to go through and secure the management plane. Now see this, disabling finger, pad, UDP, and TCP small services, enable service password encryption, enabling keep lives in, keep lives out, and disabling CDP, and disabling all these other items here. So you can see that it's doing its best to harden the management plane. Ask you to do a banner. Again, it needs to be based on your local security policy and your lawyers. Configure all the passwords. So enable secrets. I don't like the fact it wants an enable password, because I just think that's a waste if you've got an enable secret, but it does actually force you to put one in. And then you've got VTY lines and console lines. Turns off IP services on all interfaces, so it turns off these that have been used in the past by ICMP attacks. And then it secures the forwarding, so enable CEF, okay, enabling CEF, enabling Unicast, RPF on interfaces, and then if you answer yes, it will actually do a CBAC firewall, which, what a CBAC firewall, you'll learn more about it later, but what it does is it basically allows any traffic originating inside to go out, but no traffic going out, originating outside to come in. It will allow sessions that are set up from inside to out to return, but then it will close those once the session is over. So really neat little tool. Okay. Another item we need to definitely, and this is something that gets overlooked a lot, but is our routing protocols. We need to authenticate and secure our routing protocols. If not, I can drop a Linux box in here running OSPF, and it can connect to the network and start sending erroneous route table information. Now, there's two things I could do. One, I could send a route that makes all your traffic go through my device, just so I can grab a copy of it. Or I could start black holing part of your route, so just send it to null 0. Or, you know, I can just use it for reconnaissance. So back years ago, we had a network that was a flat network, and when we were learning about IGRP, you know, I looked and did some Wireshark. Well, somebody did some Wireshark looks and saw IGRP packets and saw the autonomous system it was. So I said, well, I'm just going to take one of the routers and stick it on the network, plugged it in, gave it the same autonomous system, and all of a sudden you could see all of the route table for the entire community college system. Now, I very quickly disconnected, but the problem was they had no authentication. And I could have easily injected a route in there that could have black holed all the route traffic for the community college system. So it's one of those things where as we move forward with security, and now especially since we don't have flat networks as much, we have, you know, segmented micro-segmented networks and routing out to the edges. We really need to secure these routing table updates. Well, we can do that with MD5 authentication. So you go in and you tell the router, instead of running in a non-authenticated mode, you just go in and say IP OSPF message address key, give it the key. Now notice this is something that is a little weird, because it is, you put it not under OSPF, but you put it under the actual interface itself. So it's on a per interface basis. All right, so that is a little weird. The other thing that's a little bit bad about this is it is MD5 authentication, and MD5 is not the world's most secure protocol. So OSPF version 3 actually does support and release 15.4.1. Okay, so be aware if in your lab you're running 15.0 or 15.3, and in fact, I think the currently reserved version I've got us using in the lab is 15.2, so we may not be able to do this in the lab, but with SHA you create a keychain, give it a key ID, the key string, so that's the name of the actual key you're going to use, and then you give it the cryptographic hash algorithm, okay, and then send lifetime, start lifetime, and then you put the keychain on the interface, and it will then use that for authentication. So here's a good example. Keychain is SHA-256. Key 1, the key string is OSPF SHA-256. Using this algorithm, HMAC SHA-256. Excuse me. And then we apply the keychain, which has this key in it, to that interface. And then when you apply the same on the opposite side, these two OSPF peers will now authenticate each other across this, and they will not share any information with anyone who is not part of this authentication setting or these authentication settings. Does that make sense? Pretty simple but neat. Again, the only thing I think is a little weird when you go from SHA, from MD5 to SHA, you'll see MD5 everything can be done on the interface. When you go to SHA, you have to create that keychain in global config and then apply that keychain to the interface. You're still doing it. The authentication is really being applied on the interface. You're just creating the keychain for that authentication in a slightly different place. The fact that's kind of different and the fact that it is a unique item that is new in iOS 15.4 would be something that would kind of make me want to really pay attention to that for various sundry reasons that I will leave unmentioned. So here we have our different control management planes and the data plane, and looking at again what each one does. The data plane are the user-generated packets that are always forwarded to other network devices and end stations. Data plane always has a transit IP address, and usually can be handled by normal destination IP address forwarding processes. Control plane are a little different because these are protocols such as OSPF, any of our routing protocols, any of our CDP, LLDP, anything that's used to control access to the router itself, and the destination is typically the IP address of the router for control plane packets. And then management, that is data received to manage the network or the device. So again, usually for us that'd be SSH, or maybe some type of web-based ASDM or something of that nature. Now, one of the things they talk a lot about here is that with Cisco Express forwarding, you have to be careful because it can create a large amount of initial strain on the device. You also, I like this fact, they talk about punting information. So the route processor can be less capable of handling the packets rates experienced by CEF. And so it's not going to be directly involved in forwarding the data. That's using Ceph, just comes in, the data comes in, there's a Ceph table lookup, and it goes out the egress. But if there is a large amount of overload, one of the things you can do, honestly, if there is a large amount of overload that's causing items to be punted up to the route processor or to have delays, more than likely you don't have the router that you need for that particular network. Or maybe you're getting data coming in that's just being dropped anyway, and so you need to do some ingress ACLs to drop traffic so that it's not being looked at inside the router itself. Now this control plane policing, they're talking about here, and one of the things is that the flow of traffic is punted to the route processor, and the term punt is defined as this action interface takes when sending a packet to the route processor. Control plane policing is used to keep unnecessary traffic from overwhelming the route processor. Now, we're not going to talk a whole lot about it in this particular class, but you can actually develop a policy to say what can get punted up to the route processor and what can't. So, you know, management traffic, control traffic usually gets punted, goes up to the route processor, but you can actually define what can and cannot be sent up there and what the percentages are. Again, not something we're going to cover in the class, just something I want to make you aware of in case you see control plane policing or copy. All right, there's a good video here. I'm not going to let y'all watch it. I'm not going to do it. Again, be careful with the labs. They are super long. As you know, Scott talked about. Hold on one second, folks. Sorry, that was our help desk. I thought maybe they had someone who was trying to get in or something. So that is all of Chapter 2. All right. Your next chapter will be Chapter 3, which is available and up for you. And this is where we're going to get into authentication, authorization, and accounting, or AAA. We're going to look at how we can configure AAA, both using a local database and also going out to another system like Cisco's ACS, or other systems that are available out there. It's the Identity Services Engine, which we don't have. And so we're going to be looking at that as part of our Chapter 3. I am going to stop and ask if there are any questions. A little bit shorter today because we're going to stop before we get into Chapter 3. I'm going to stop the recording.